There's a secret physicists don't tell you. Every law you've learned, Newton's laws, conservation of energy, even relativity, they're all shadows, reflections of one deeper truth, and it can be captured in three symbols. Delta S equals 0. But first, what makes a law? Not a suggestion, not a rule you can break, but something absolute, something the universe itself cannot violate. In physics, maybe 5 principles rise to that level. Conservation of energy, conservation of momentum, the consistency of light speed, a handful of others. And today, you'll see they're all the same thing. They're all just different ways of saying delta S equals 0. First off, I should explain what delta S equals 0 even means. Delta just means change or variation, and S is a quantity called action that equals mass times distance times velocity integrated over time, which, if you don't know calculus, just think of as adding up all the values of mass times distance times velocity as it changes throughout time. Action might sound abstract, a strange number combining mass, distance, velocity, and time, but the easiest way to understand it is with your own body. Imagine pushing a heavy box across the floor. What matters isn't just how heavy it is, or how far it moves, or how fast you push it, or how long you push. It's the entire package of effort. That package, that lived felt resistance, is action. Heavier box, the effort piles up. Farther, the story grows. Faster, every muscle counts more. Longer, the ledger fills. Action is the total story of effort throughout space and time. The universe doesn't measure just energy at a moment. It measures the whole exhausting grid of getting something done. Here's what most people miss. We feel action instinctively. Your muscles know it. That burning sensation when you're straining, that's not just energy expenditure. That's action accumulating. The physics equation is just bookkeeping for something your body already understands. Now, here's where things get strange. You've probably heard of the principle of least action. It sounds like the universe is lazy, always picking the easiest path, but that's completely wrong. It's not about least effort. It's about stationary effort. Imagine rolling a marble into a bowl. At the very bottom, nudge it slightly left, it rolls back. Nudge it right, it rolls back. Its height barely changes with small movements. That's a stationary point. The marble isn't at the lowest point in the entire universe, just at the lowest point nearby, in the bowl. That stability, that's what delta S equals 0 means. The real principle says this: nature picks paths where tiny changes don't alter the total action. Not paths with minimum action, not maximum action. Paths where the action is stable, balanced, where small wiggles produce almost no change in the ledger. But here's what blew my mind when I first understood this. This isn't just mathematical elegance. This explains why anything is stable at all. Think about a planet orbiting the sun. Why is the orbit elliptical? Why not a spiral? Why not a figure 8? Why not chaos? Because those other paths aren't stationary. Watch what happens. Put the planet on a spiral path. Calculate its action. The total effort of its motion through space and time. Now nudge it slightly. Change its position by a millimeter. The action changes dramatically. That path is unstable. The slightest perturbation destroys it. The orbit can't persist. But the ellipse, nudge the planet slightly on its actual orbit, the action barely changes. Delta S equals 0. That orbit is stable. Small disturbances don't destroy it. It can exist. It can persist across billions of years. This is the secret. Delta S equals 0 doesn't just describe motion. It explains why stable patterns exist at all. Orbits aren't mathematically convenient. They're only paths the universe can sustain. Every stable structure you see, planetary systems, atomic orbits, the arc of a thrown ball, exist because it's a solution to delta S equals 0. The universe isn't optimizing for minimum effort. It's filtering for stability, and stability means stationary action. Now, watch how everything else emerges from this. Energy, that's action measured at a single instant. Energy tells you how hard you're pushing right now. Action tells you the complete narrative, how hard, how far, how long, all woven together. Momentum, That's the directional accounting of action. When two objects collide, momentum is conserved. You learn that in school. But why? Because action demands it. The ledger must balance. Delta S equals 0 applied to collisions gives you momentum conservation automatically. Forces? Not fundamental. Just a bookkeeping shorthand in the action ledger. Push a pendulum and you feel resistance. That's not the force causing motion. That's the universe enforcing delta S equals 0. Newton's third law, every action has an equal and opposite reaction. That's just action bookkeeping. Push on a wall, the wall pushes back. Why? Because if it didn't, the action wouldn't be stationary. The math wouldn't close. Even light obeys this. Photons don't choose to travel in straight lines. They're following paths where action is stationary. Near a massive object, space-time curves. The stationary path curves with it. Light bends near stars not because gravity pulls on it, but because curved space-time changes what delta S equals 0 means. From the largest orbits to the tiniest particles, the same principle rules. Let's shrink down to the quantum world. Here's where this gets truly strange. At quantum scales, particles don't even fully follow a single path. An electron going from point A to point B doesn't pick one route. It explores every possible route simultaneously. Every straight line, every wild zigzag, every absurd loop. Some of these paths are pure chaos, like a drunken ant on a caffeine binge. And yet, here's the thing. Every possible path contributes to the story. Most cancel out. They interfere destructively. Only a few paths survive, where action is stationary. Those are the ones we actually see, where delta S equals 0. And it's not just in classical mechanics. It's quantum mechanics. It's the same law, just wearing a different mask. This isn't abstract. GPS satellites prove it every day. Those satellites orbit at high altitudes where gravity is weaker. Einstein showed that time runs slightly faster in weaker gravity. The difference? Microseconds per day. But light travels 300 meters per microsecond, or 1 million times faster than your fastest sprinter. Ignore this effect, and your GPS would drift by kilometers within hours. Your phone would think you're in the middle of the ocean in under an hour. Why does gravity affect time? Because space-time itself is minimizing action. The curvature isn't arbitrary. It's the only geometry where delta S equals 0 holds everywhere. Every map on your phone, every navigation system on Earth depends on this principle being exactly true. And this same principle governs particle colliders. When CERN smashes protons together at 99.9999 the speed of light, they're probing reality at the smallest scales we can reach. What do they find? Particles appearing, vanishing, transforming. Chaos, right? No. Every decay, every creation, every fleeting interaction all obey delta S equals 0. The universe keeps its ledger precise down to the 10 to the negative 24th seconds, or a millionth of a trillionth of a second. Even there, nothing slips through. The randomness isn't lawlessness. It's probability distributions that emerge when countless particles each follow the same principle. So let's get back to that box. You're pushing it across the floor. Mass, distance, time, velocity, all combining into one lived experience of effort. You're not just moving an object. You're negotiating with the deepest law in nature, the same principle that governs you push govern galactic rotate. So let's get back to that box. You're pushing it across the floor. Mass, distance, time, velocity, all combining into one lived experience of effort. You're not just moving an object. You're negotiating with the deepest law in nature. The same principle that governs your push governs galactic rotation. The same ledger that tracks your effort tracks the sun's fusion. Every throw, every orbit, every atom, every photon, they all solve delta S equals 0. But we didn't invent this principle. We discovered it. For billions of years before humans existed, reality was already using it. Stars were already following stationary paths. Atoms were already balancing their ledgers. The universe knew delta S equals 0 long before we had symbols to write it down, which means something profound. The laws we study aren't human constructs. They're not convenient summaries. They're glimpses of something that was true before consciousness, before Earth, before galaxies were formed. We're just catching up. We're learning to read a book that was already written. one law, delta S equals 0. Everything else, Newton's laws, conservation principles, relativity, quantum mechanics, they're all just different chapters, different ways of counting the same cosmic ledger. The universe measures effort. Change has consequences. Stability emerges from balance. And that iron rule holds from the quantum foam to the cosmic web without exception, without loophole, and without mercy. So, the next time you push something heavy, feel that resistance. That's not just your muscles. That's you physically experiencing the law that holds reality together. Next time you push, lift, or throw, remember, you're touching the same law that shapes galaxies, atoms, and the very flow of time. Every decision you make, every path you trace, every pulse of energy, even if you don't see it, echoes the universe's ledger. You are part of delta S equals 0. Pretty wild, right? If this changes how you see physics, or broke your brain even a little, let me know in the comments. What other laws should we tear apart next? And if you want more physics that actually makes sense instead of just memorizing equations, hit subscribe. Trust me, we're just getting started.